RAM is short for random access memory. Sometimes it's called volatile memory because when your computer program ends, any information that was stored in RAM is forgotten. It's eliminated. If your computer were to accidentally turn off, well, your program has ended because your computer's off, whether it's because you lose power, your battery runs out, someone trips over the power cord, or there's a major computer crash. Regardless, that program's not running and all that data is forgotten. So therefore, we have to have a way, how are we going to be able to store data that we can use over multiple sessions of running this application? Or maybe we need to have a couple of applications and one reads in data and creates data periodically for us, and then we have another application that reads that data later on. Sometimes we need to be able to transfer data between different applications. One may be written in Python, one maybe not. Well, in cases like this, there are a couple of options. The easiest way is probably to use a file. And there's a couple of different types of files, and luckily Python makes it relatively easy to work with any of them. The ones we're going to look at, though, are the simplest. The two major types of files that we'll look at are text and binary. Now, a text file is stored in either an ANSI or a UTF encoded file. And what that means is it's very similar to what you see normally on a screen. So this means that you can open up inside of another text tool, maybe an application like Notepad or TextEdit. You can open it inside of a more complicated tool like Microsoft Word or Google Docs, and they'll be able to read it. You can see it, you know what it says. You can often edit it there as well as reading it. Binary files encodes all that information into a binary format. This is especially important if you have a lot of numeric data. Because what happens is instead of seeing a number 1, 2, 3, it encodes it as it would internally when it stores it in RAM, and that's usually a smaller amount of data. Now, the downside to that is that binary data usually has to be read by an application that's designed for that. So if I go in and take an Excel file, I can't open that in Notepad and be able to really make sense of it. Okay? It's a binary format. So therefore, we have to work with the right tool. If we don't have access to that tool, we can't read and or edit that data. So there are pros and cons to both. We're going to work with text data just because it's a little bit easier to work with, especially when we're getting started. Now, like I said, there's 4 types, and we mentioned text and we mentioned binary. Well, each of those can be subdivided down into 2 more. And that's a sequential file and a random access file. A sequential file is a file that's designed to be read from beginning to the end. On the other hand, a random access file is designed to be skipped around in. So let's say that you have a video, a movie, and you want to skip ahead in your MP4 file that you're watching this movie on. Well, you can jump ahead. You don't have to watch it in the specific order. You can jump ahead 5 minutes, 10 minutes, whatever you need to. Now, typically you often will start and watch from beginning to end, but you don't have to because maybe you watched that first part yesterday and now you have to come back and finish it up. So there's a couple different ways. Your random access is a little bit more complicated because usually it's binary. That lets you know how far to jump and have indexes into the file. And that way you can say, oh, I want to jump. This is a list of all my friends and all their addresses and email addresses so I can contact them. And so I need to be able to jump. I need to know how big and where those indexes are to get to those people. Does make it a little bit more complicated. So therefore, we're going to start with sequential data. That means that we're starting with the easiest of all formats, text that's sequentially stored. So let's look at how we're going to work with our files. Now, our files are going to use the same basic principle regardless of what we're going to do with them. Now, our files are going to work pretty much the same no matter what we do with them. And there's 2 major operations that we'll do. First, we can read from a file, and we can also write to a file. In both cases, they're going to follow a similar format. That format is going to be we're going to open a file, we're going to do something with it, and then we're going to close the file. So we need to do those 3 steps. Open, operate, or do something with it, and close. Luckily, Python makes this very, very easy for us. Now, regardless of what programming language you're going to use, these three basic steps are going to be the same. Python does make it very easy for us, and it's easier than some other languages, and we're going to look at how we're going to do that. So let's go ahead and start by looking at how we're going to use Python in order to do these steps. So here I've created a new file inside of Visual Studio Code. I'm going to create my main function. Remember, we talked about functions in our previous module. We always want to follow good form. So I'm going to specify def main. You have things I'm going to do, and then I'm going to say if remember, this is just good programming standards. Now, it does show me a little bit of an error right now. That's just because I don't have anything inside my main body. Python does not like it if you declare a function without giving it a body. So let's go ahead and start that process. Anytime I'm going to work with a file, I need to have a way that I can reference it when I'm using it. So therefore, I want to have a good name that I can reference. So I'm going to call this, just as an example for this case, file input. Now, file input is because I'm getting data in from my file. I'm reading it in. And so you might call it file in, you might call it in file. I'm just calling it file input. And then we're going to specify a command that we're going to use. And this is going to be open. Now, open is a built-in function that Python provides for us that's going to allow us to open a file. Now, this open command is going to take two parameters. The first is going to be our file name. Now, I could specify something like C:\data, and then, go through my folder list, my file list, etc. And this would technically work. However, it might be different on your machine. So we have to be very careful of that. This is known as an absolute path. The problem with absolute paths is your machine may not be laid out the same as my machine. That can cause issues. If you are on a different operating system, this can cause issues because how a Macintosh or Linux machine stores files versus a Windows PC like I'm using, it's going to have some issues. So the other option is to reference a relative path, and that is from where I am, where's the file I want to read. Now, I've already created a file. It's called data01.txt, and this is going to let me open it. Remember, I said that the open function takes two parameters. One is your data source. The second is the mode. The mode is how do I want to open this file, and I can open it for reading or for writing. And so I'm going to specify R for read. Now, let's take a quick look at what is this data01.txt. Well, if I come over here into my file list, I can select data01.txt, and you notice it just says hello world. Okay, that's pretty easy. So we've seen things like this before. We're going to work with this. I'm going to close that so we come back here. Now, remember the three steps. First is open the file. Second is going to be do something with the file. So to do something with the file, we need to read it. There's a couple different ways we can read, but I'm just going to real quickly read the entire file. So I'm going to call this info equals, and we have to say file input, because remember that's the file that we're referencing. That's the one that we just opened. That variable name now references that file. You can say dot and then read. This is going to read by default the entire file. This can cause some problems if it's dealing with a very large file, but since this is a small file, it's not going to be an issue. Then remember, I need to close my file when I'm done with it. So I'll say file input dot close. Now, I did this for a very important reason. Okay, so I opened my file, I read in my files and stored it to a variable, and then I closed my file. But because I put the contents of the file into a variable, I can use it later. So I can say print info, and because this variable was created inside my main function, and my print info is inside my main function, that's still there. Even though I close the file, the data is in that variable. So I'm going to come over here and run it. And down in my terminal window, it prints hello world. Now I'm going to open up my data 01. And add a new line. Welcome to class. Close my file, and if I run this again, notice without any changes to my code, it now prints hello world, welcome to class. And I could change and add more things to that file. I don't have to make any changes to my program. It's going to work for me. And that's a really, really nice thing. It makes it very simple and easy to work with. Now, there is a couple downsides to this program, however. For example, my read reads the entire contents of the file. What happens if I want to split that up into individual lines? Well, let's show you how we can do that real quick. I'm going to delete line 3, which is info equals file input dot read. And I'm going to call this line 1. That's going to equal file input dot read line. This is going to read one line. Now remember, right now I have 2 lines inside of my file. So this does cause a problem. So I would have to say, well, line 2 equals file input dot read line. And then I can't print info anymore. I have to print line 1. And then I have to print line 2. I can save this. I can run this file. Notice that it does it like this. There's 2 issues right away that you might see with this. You can see here from our previous example, hello world and welcome class were right next to each other. Now I have hello world, and then the read line actually read the new line character at the end of that line. And so when it printed the new line, and then the print says, oh, I'm at the end, it prints a new line and gives us a blank line. So it's not ideal. There are ways to fix this. We could remove the new line character from our line 1 string. That would work. The problem with that is, while it does work, we haven't learned how to replace characters yet. We have learned how to change the end of the print statement so the end doesn't print a new line, it prints a null character or just kind of an empty string, if you would. That would work. There's a couple of ways, like I said, we could fix this. This isn't a big issue, so we're just going to leave it for now. Now you might look at this, however, and see a potentially bigger issue. And let me show you what that's going to look like. So I'm going to come back here into data. I'm going to add a third line real quick. Intro to computer science. Now, let me do a CLS on my terminal so it's clean. If I go and run this, you notice it says, hello world, welcome to class. Didn't I put a third line there? Yes, I did. By using the read line function, that's what it's looking for. And I have to tell exactly how many lines are in my file. And if I'm wrong, then I have some issues. Okay? So I have to know how many lines it is. Luckily, we have a couple ways that we can fix this. We can use a loop. And I can use a while loop if I want to, or I can use a for loop. And a for loop actually works a little bit easier than this method. So I'm going to delete lines 3 and 4. And I'm going to create a for loop. For, and I need to give a variable for what line am I working with. So I'm just going to call it line. This is going to be my current line. In file input. And so file input is now acting like a list of data because it's got a list of lines. The for command allows us to iterate through that file line by line by line. So now I'm going to come into line 4, and now because I'm using a for loop and line is created inside that for loop, I'm going to have to print it here. I can't close the file and then use as variables. This is used one step at a time, and this is a potential issue. Okay, so remember, we always do the open, the file process, and then we close the file. So now we're doing the file process and doing some other things. It's generally a best practice to close a file as soon as you can. And there's a lot of reasons for it, including your operating system typically only lets you have so many files open. Sometimes it will limit it by process or application. Sometimes it's a hard rule over how many files total can be opened. Most modern operating systems are going to give you so many files that it's not going to be an issue for you, but it's still a good practice. Part of it is, what happens if you have a file open and your application crashes? No one knows. It's what's called indeterminate. It depends upon how your file was opened, was someone else trying to access it. You could corrupt your file. You could have nothing happen to it. You just don't know. Now, with just reading a file, it's probably not too bad. Writing a file is going to be a different story. We're going to see that in a minute. But for right now, let's just do this, just so we can see this in an example. So I'm going to save this file and then run it. And you'll notice that it now prints all 3 lines. And I could go in there and add a half dozen other lines. It would print them out one by one. Now, I've created a data02.txt, and it is the soliloquy from Hamlet, to be or not to be. And you can see this right here. And the reason I want to do this is I want to make one small change to our sample 5. We're just going to change it to be looking at data 02 instead of data 01. That's the only change we're making. But I want to show you the power of using that for loop instead of using an individual line. Notice, remember, all I changed was what file does it point to. And now if I go and run, you can see all that information in there. Now you do see there are a special couple of characters in there that is not displaying quite right. That's because right now I'm set up to use ANSI data, and it's probably UTF data, probably an apostrophe instead of a single quote. That's a negligent minor issue. If I come over here and change that to a single quote, we wouldn't have any more issues. But you can see that 4 line in my data file. When I just changed what the file was pointing to, it made it very easy to get new data. And that's actually part of the real benefit to using files, is I can simply point to a different data file, and I can have some sample data and then say, okay, now let me point to my live data. And my sample data might have 10 or 15 lines of sample data just so I can process and make sure it's converting correctly. And then I point to my live data that might have 10,000 or 100,000 lines of data in it. And then if my 10 worked, that 10,000 will probably work. And yes, I have actually done this in real production environments. You set up, you run some tests, you want the tests to be pretty quick, they only take a couple minutes, so you just give it a small subset of data. Or maybe we give it sets of data. We say, okay, let's check these 10. Okay, it works, let's check on 1,000. Let's see, okay, it works good. Okay, we ran that over lunch. Let's do the 10,000. This is going to take us 4, 5, 6 hours to run. I've had applications that I've written that have taken over a half a day, in some cases close to a day to run, just processing large amounts of data. And so what do? Well, we set up to run when we go home. And I say, okay, time to go home. It's 5 o'clock. You hit the run button and you go home. And when you come in the next day at 8 o'clock in the morning, 9 o'clock in the morning, whenever your day starts, hopefully that file is there. And you've done some testing. You've got a pretty good feeling if it's going to work or not. And so you just keep working with that type of data. It's a pretty simple and easy process to do. And so this is a nice thing. The second thing I want to show is just how easy it is to use that for loop, because now it works regardless. And you can have, 5 lines, 5,000 lines, 50,000 lines. It's just going to keep churning and working through that. Now, you do notice here that we have that input where we open, we process, and we close. Python has added another way of doing this because some people forget to put the close. Now, I always like to tell people, I kind of hear my mother in the back of my head. If I go in the kitchen and open a cupboard or something to get something out, she'd always be like, make sure you close that door, make sure you close that drawer, make sure you close the fridge, make sure you, okay? If you open it, you close it. And this has helped me, and I remember how to do it because I kind of hear my mother in the back of my head telling me these things. Now, maybe you didn't hear that, and maybe other people did. And they said, oh, I forget to close, and forgetting to close files can cause problems. Remember, we talked about it accidentally. What happens if your application crashes? It can cause a problem. It can corrupt a file or leave a file open so it can't be accessed by anyone else, or a variety of other things like that. So there is another way to do this. I want to show you that slight change. And this change is going to be on line 2 where we open. So I'm going to delete that part, and I'm going to say with open. And with is a special command that's going to allow us to create a block, but it's going to do the open and close for us essentially. So with open, and then I specify data 02, I open it for read. That's all exactly the same. Then after my open command, I'm going to say as, and then I'm going to assign the variable file input. Then I'm going to put a colon. So remember, all my blocks of code, anytime we have a block, I put a colon before I start that block. We've seen this in if statements, loops, and functions. Now we're seeing it with this with command. And I'm going to take this for line in file input. I'm just going to indent it. When I do that, I no longer need line 5, which is to close my file. The with open will automatically close the file with it. And you can only access that file inside of the internal block for the with open. I'm going to save this. I'm going to CLS in my terminal just so I can see what's going to happen. And I run, and notice it prints out the exact same thing. Why does it print out the same thing? Because it does the exact same thing. It does the file open, and then it does the close for me automatically. Now, is that with open really easier? For me, I don't find it that way. But there are a lot of Python examples out there that use this, and I want to show you it. And you might think, oh, I don't have to remember to close it. This is going to be great. And so you're going to use it. And that's fine. There's nothing wrong with using it. It's just another little way that Python is trying to make our lives a little simpler. Sometimes the things it does to make it simpler really, really works. Sometimes I kind of, in this opinion for myself, it's like, maybe. Okay, so just something to kind of think about and remember. All right, so let's look now at how do I want to write a file. Well, write a file is going to be very, very similar. And I'm still going to use the with open just because we've started using that. I'm going to make 2 changes though. I'm going to say data 03, and I'm going to specify W for write. Okay, there's actually 2 different ways that we can write. We can write where it's going to create a brand new file, and then we can write where it's going to append to the end of a file. So I'm going to just say write. And then instead of file input, this is going to be file out because we're writing out. Okay. So now we need to send some data to our file. So let's start off with something simple. I'm just going to write data to it. So I'm going to say file out dot, and notice Visual Studio Code is really smart. It knows that we open file out for writing, so the first option it gives me is to write, not to read. I think that's great. So I'm going to specify write. What am I going to write? Well, 2 things I need to keep in mind. This is a text file. I need to write a string. So if I try to write 13, it might give me an issue. Instead, I need to convert 13 the number into 13 the string. str, open parenthesis, close parenthesis, and you're good. str is kind of like the opposite of int. int takes a string and converts it into an integer number. str takes a number, whether it's a float or an integer, and converts it into a string. That's pretty neat. Okay, so I'm going to write this real quick. I'm going to clear my terminal screen by doing CLS. I click run, and I don't see anything happen. Well, remember, we didn't print to the screen 13, we wrote it to a file. And now if I go over to my file list, you'll see there is a data 03. Okay, and I'm just calling these data 01, 2, 3 just to make it easy to see as we process these. And if I write it, you can see there's 13. That's pretty cool. Okay, that's easy. I'm going to go in and change this real quick. 45. If I run this, notice nothing happens down my terminal window, but if I come over here to data 03, notice 13's been replaced and 45 is now there. And that's because every time we open that file, it erases the contents and deletes it all, and we start from scratch. If I wanted both lines, I have to say file out dot write 13 and then 45. If I run it again, you notice I write 1345. Wait a second, I wanted 13 and then I wanted 45. This is why we always chest. Okay, so when we write exactly what's there. Python does not put a new line character because it doesn't know if we need a new line character. So if I'm going to want to have it separate, either adding a space or putting a new line character in or anything like that, I have to specify inside my file out.write. Now there's a couple things I can do. I can concatenate the string. And concatenation is adding two strings together. So I can say 13 plus a new line character. Okay, that's one option I can do. You can see if I run this here. Now when I come back to my data 03, you see 13 and you see 45. Okay. Another option, just to kind of show you, is I might say something like Jenny put a new line character in the next write statement. Have a number here. If I go and run this, 867. Okay. So I have some options that I can do. I can print it as part of a concatenation. I can put a new separate line in there. There's a lot of things that I can do. It makes it really easy to work with. Okay, but writing becomes very, very easy for us. Now, remember, in this example, we're writing over our data. Is that always good? Well, always is a strong word. There are times and reasons to do it that way. Whether or not it's the best for what we're doing now, that depends upon our application. So, for example, I had an application that I wrote that we had to write log files for. And this is a semi-common thing. Well, we wrote a log file, and part of it is we added to the name, and it only ran once a day. It created a file. We wrote the logs. If we ran the application twice in one day, the log files got deleted, and we were okay with that. But it's often where if I create a file, I need to just append to the end of it. I need to keep working. So let's show you how we're going to change that real quick. Well, it's super easy. I'm going to say with open data3.txt, I'm going to specify A. A is short for append. Okay, so R is short for read, W is short for write, A is short for append. And I can come in here and do something like data equals input. What do you want to save? And then I can say file out.write data. And then I might go ahead and put a new line character there just so we automatically have it ready. Now if I go and run this, down in my console terminal, I see, oh, what do I want to save? 5. Enter. If I select data 03, Jenny 867, it put the 5 on the same line because there wasn't a new line character already at the end of 867. That's acceptable. Now there's a new line character here, and I'm ready to put data in line 3. If I go and run this again, 309, pull this up, Jenny 8675 and 309. So if you don't know the reference, it's an old song from the 80s. You can kind of look it up if you're interested. What's interesting with this, though, I just want to show you, just as an example, I'm going to go ahead and put a song from the 80s here. And I'm going to put a new line character, and then I'm going to give it some other information. Okay, so I just give it some random information. I have my application. I'm going to run this real quick. I'm going to say hello again. Now, what do you think happened with my file that had the information, some which I loaded with this application, some which I typed in manually? Well, this is the great thing about working with files. Notice that it kept all the information that I worked with and then printed out hello again and added it to the file. So my file can actually take information from different data sources, write it to one file that I can then manipulate and work with in a later application or later part of the same application. And remember, we said it was important to close a file. And that's because if I have it open for writing, you can't open it to write. It's going to cause an issue. Okay, so there are those types of things we have to look at and we have to think about. And this makes it very, very important to work with and to process. So that's why we always say close the file as soon as you can, because you need to let other people have access to it. It's not just protection from corruption in case your application crashes, which is granted a very important thing to think about, but it's also a matter of, hey, is this on like a network share and other people are using it? How is it being processed? These are all important factors as well. Now, the other thing I want to point out is, remember I said that because this is a text file, we had to write strings. We couldn't write numbers. And you might say, but hey, you typed in some numbers. How did that work? Well, remember, when I typed them in, they were captured by the input function. The input function always collects a string. When we collect a string, it doesn't cause any issues with writing it to a file because the file is expecting a string. We have to convert it to a number if we want to do some math on it. And if we want to write that number to a file, then we'd have to convert it back to a string. Now, that conversion process is real important to remember when you're working with a computer language. And you have to understand what languages can do what. So some of them will allow you to write numbers to files. Some of them said, no, it has to be a string like Python does. The key thing to remember is, what language am I working with? Understanding its idiosyncrasies and understanding just that process. So just kind of keep that in mind. That's why we didn't have to here. With other languages, we might. But this whole process and what we've shown you is all you need to know for your basics on how do you read and write files. We looked at using text files because that's a little bit easier. And then we looked at being able to read files, overwrite the file, and append to a file. Now, you might ask one final question with the append. What happens if my file doesn't exist? Okay, so the answer is real simple. It creates it. And it's the same thing as doing a write. If it does exist, it opens it and then puts the cursor at the end and lets you write from there. You might ask, well, can I write to the top of a file? Kind of like you would expect to see your Twitter feed where you see the most recent things first. And the answer is by default, no. Computers work sequentially, and so they're going to put things at the end. If you want to have something in a reverse order feed like you would see on Twitter or Instagram or some other social media thing, you would have to write that. And you could write it, read in the old data, write the new piece, and then write the old data. And that would actually put it in reverse chronological order of how it was entered. So that is possible for you to do. We'll look at potential errors that you might have in the next module, next section. So be ready for that. But for right now, this is all the information that you're going to need for working with files.